So now we have learned about two types of hypervisors. So the first type being the bare metal hypervisor, where the hypervisor are present on the hardware and lets you install multiple VMs on the machine. That is why it is called a bare metal hypervisor. And the other thing that we have, or the other type that we have, is the type 2, that is hosted hypervisor. So a hosted hypervisor runs on a conventional operating system or OS, just as any other computer program does. So the type 1 hypervisor, also called as the bare metal hypervisor, comes as a part of the physical hardware and sometimes has to be enabled from the BIOS if not enabled by default. And that is also called as the host. And the VM that is hosted on that is called the guest operating system. And the hypervisor actually treats the resources that you have, such as CPU, memory, storage, as a part of the resource pool, and thus are able to allocate these resources for the VMs that are created on top of them. So the common type of type 1 hypervisor are the ESXi hypervisors from VMware, or also called as ESX integrated, or the Hyper-V that we have, which is also a type 1 hypervisor. And this type of hypervisor can help you with the hardware assisted virtualization. Now let's come back to the type 2 hypervisor, also called as the hosted hypervisor, that runs on the conventional general operating system, just like a software application. So you have the hardware on top of which you install the operating system, that is your host operating system, and you install the hypervisor as an application on your host operating system, and which will help you run multiple operating systems as a part of your VM creation list. These hypervisors can be installed on the data center or the local computer that you have. Oh wait, this is same for the type 1 hypervisor as well, but that also can be installed on the local computer if you have an embedded hypervisor that comes along with your system. So don't worry about that, just like the dual boot that you used to do. But the difference is that you install type 2 on the OS itself. Here what the hypervisor does is it actually abstracts the guest operating system from the host operating system, and that is how you are able to allocate resources to your VM without having the host operating system object you from what you're doing. The best examples are VMware Workstation and Oracle VirtualBox, because I have used them, so it should be good. Just kidding. With that, you will be able to create your own VM and you will be able to run Ubuntu or any other Linux or even Windows on the same operating system at once. But even though I've shown you a great deal of why virtual machines are awesome, they do come with their own shortcomings. Let's see that. So the virtual machines that we have here provide an isolated environment for your applications to run, and even though your VM is compromised, it won't have much impact on the other VMs. But what if the hypervisor is itself hacked? Then it will have an impact on all the VMs that you have provisioned. That would be bad, isn't it? So you need to understand here that the virtualization comes at a cost, and the cost is that the hypervisor virtualizes the physical hardware itself. And each VM that you see here runs a full-fledged operating system and utilizes more resource, which could be very frustrating if you are tight on budget and resource scaling. Even though you allocate more CPU, RAM or storage to your VMs, there will be a time when you will feel the heat of the slowish VMs. For example, running multiple applications like microservices. Can it be done using VMs? Yes, it can. Will it cost? Yes, it will.